Assalamualaikum and hi. We from Group 3 CDCS 1102A will discuss about the topic application of differentiation, graph of polynomial function. Before that, let me introduce myself and follow with other team members. My name is MOHAMAD AIDIEL, and at the middle is MOHAMAD DANIAL, and last one is MOHAMAD NAZHAN. Without further ado, let's proceed into the introduction of the topic.
So to start the introduction, we have to look to objective first. So the objective is to help develop your intuition of the general behavior of polynomial function. So on this topic, we will find x-intercept and y-intercept, the critical points, the interval points, maximum and minimum points, increase and decrease interval, and concave up and concave intervals. So before we go through the question, what is a graph of polynomial function? So the graph of polynomial function is visual representation of the function behavior. It is a curve that may have various shape and a pattern depending on the degree and the coefficient of the polynomial. So let's look at the problem statement first. So the question are given is a function f(x) equals to x cubed minus 3x squared minus 9x plus 2. So the first one is to find the x-intercept and y-intercept of f function. Okay, and the second one is to find the intervals where fx is increasing and also decreasing. Hence, determine the relative extremum of f function. And the third one is to find the interval where f function is concave up or concave down. Hence, determine the inflection points if there is any. And the last one but not least, sketch the graph of f function by using all of the above informations. So for the first solution, we have to find x-intercept and y-intercept of fx. So we have to find x-intercept and also y-intercepts. So for the first intercept, which is x, we have to let y equals to 0. So 0 is equals to x cubed minus 3x squared minus 9x plus 2, which is y is equals to fx. So fx is equal to 0. So then we put in calculator on the polynomial function, which is cube, and then we got s equals to 4.7913, s equals to 0.2087, and x is equals to negative 2. And the x-intercept is 4.79130, 0.20870, and negative 2, 0. So let's go for the y-intercept. So if x-intercept is y equals to 0, then y-intercept is x equals to 0. So we just put 0 on x in the fx. So fx is equals to 0 cubed minus 3 0 squared minus 90 plus 2, and then we got 2.
For the question Roman 2, find the intervals where fx is increasing and decreasing, hence determine the relative extremum of fx. The question already give a fx equation, so we need to differentiate fx. So we get f prime x equals to f prime x equals to 3x power of 2 minus 6x minus 9. But since all the number is odd, so we can divide into 3, and we get f prime x equal to x power of 2 minus 2x minus 3. So we need to find the x value. We sign f prime x equal to 0. And then we EQ, and we get x equal to 3 and x equal to negative 1. To find the critical point or extremum point, we use the x value but using fx equation. So when x equal to 3, we get y equals to negative 25. When x equal to negative 1, we get y equals to 7. For this point, we can determine for the maximum point and minimum point. And then we need to draw a line by labeling x point, which is negative 1 and negative 1 and 3. And then we can see there's 3 intervals that we can write. The number 1 is negative infinite, negative 1. The number 2 is negative 1 to 3. And third is 3 positive infinite. And then we need to draw the table. It contains the interval, test value, sin f prime x, and increase or decrease. So we insert all the intervals and then give the test value. For example, negative infinite to negative 1, we test value 2. And then we substitute the test value into the f prime x. So we get 5. So sign f prime x will be positive and graph will be increased. Same goes to -1 and 3 intervals. We give test value into the 0 and then insert into the f prime x equation and we get -3. So sin f prime x will be negative and graph will be decreased. And lastly, 3 to positive infinity, we give the test value to 4. Insert 4 into the f prime x where we get positive and then the graph will be increased. So for increase point is negative infinite to -1, unite 3 to positive infinite. The decrease point is -1 to 3. Maximum point is -1 to 7 and then the minimum point is 3, -25. For maximum minimum point, we can determine for looking the intervals.
Question Roman 3. Find the interval where fx is concave up or concave down. Hence, determine the inflection point if any. First, we differentiate this first equation and we will get f prime equal to fx power of 2 minus 2x minus 3. And then we differentiate again and we will get 2x minus 2. We differentiate 2 times to find the concave up and concave down. Then next, f double prime x equal to 0. And find the x value and we will get x equal to 1. To find the inflection point, use the fx equation, put the x value into the fx equation. When x equal to 1, we will get -9 and we will get the inflection point. It is 1 and -9. And then draw the line and label as 1 and we will get the first interval. It's negative infinite and 1 and we will get the second interval 1 and positive infinite and then we test the value to find the concave up and concave down. Substitute all the test value into f double prime x. When x equal to 0 we will get -2 and when x equal to 2 we will get the 2. When we get the negative number, we assign it as a concave down. When we get the positive number, we assign it as a concave up. So concave up is 1 and positive infinite, and concave down is negative infinite and 1. Inflection point is 1 and -9.
Question Roman 4. Sketch the graph of fx by using all the above information. For this question, we need to list down all the points that we already get from question Roman 1, Roman 2, and Roman 3, such as like x-intercept, y-intercept, maximum point, minimum point, and inflection point. Second, we need to draw x-axis and y-axis line. Third, we need to plot all the points that we already get from this. Lastly, we need to draw a line which touch all the points that we already plot in the graph. So this is how it looks like when you already done plotting the graph.
In the end of the assessment, we are able to be more prepared to face the final test, and we are able to draw graph accurately and effectively. And we are able to find points that are required to draw a graph such as x-intercept, y-intercept, maximum and minimum point, critical point, and equation point. That's all from us. Thank you.